SLS, selective laser sintering, is this additive manufacturing process that wants to scale in terms of the quantity of parts that it produces. SLS is the additive process particularly well suited to production. I'm doing this series of videos on the SLS Mindset with Nate Stevens, Operations Director of Lifestyle Additive. Hi, Nate.
Hello. Thanks for joining me.
Happy to be here. This has been an interesting series of videos, and check out other installments we've done. We've done pieces on how to design for strength in SLS, how to design for precision, how to design for cost savings. But in this episode, we're going to talk about maybe one of the most fundamental SLS advantages of all, which is the freedom to dramatically increase quantity. These machines behind us are production machines. As strange as it may seem, for as quiet and as clean as this facility is, we're sitting in a production facility. And Nate, when you design parts for people, often they come to you as prototypes, and in almost every case, you think, okay, this is going to be production eventually, so I'm designing for that in mind.
Well, I like what you said about it. It seems like maybe this isn't a production facility. Machines tend to not occupy a lot of space. You tend to not need a lot of people to run those facilities, and we can get a lot of parts out fairly quickly. The name of the game, though, with production is reducing post-production time.
SLS, is that happening on these machines, or is there something more you'd say about it?
SLS is everything in this room. A lot of people think SLS is just the printer, it's just the materials, it's just the laser. It's not. It's every step of the process, from nesting the parts in the software to printing to cleaning to smoothing. And what I mean by reducing post-production time largely has to do with removing powder repeatedly, making the product in a way that it can be easily inspected, easily assembled, making it in a way that can be easily packaged and shipped.
Can you give an example of a design change that maybe didn't change much in the actual 3D printing that takes place on these machines, but changed something substantial about post-processing?
This handle here, it's got some deep cavities in it. One thing that we changed on the modeling side of it is we added a little cork feature in there that allows us to remove the bulk of that powder very quickly.
It's basically a temporary tool for getting a lot of powder.
Yeah, and very minimal material used. We save tenfold in the amount of time that it takes to clean these parts. Another good example is this part here, these kind of long cannulated parts. And what I always recommend is adding what I call windows to the part to allow the media to come in and remove the material from those cannulas. It reduces the amount of interaction that we have to have with the part. Cleaning these parts was a 10 to 15 minute process without the windows. Now it's like a 30-second process.
This is an example of a part in the black nylon material that you've been working with. And one thing about this material is it really benefits from the vapor smoothing. Is there anything you want to say about vapor smoothing as a post-processing operation and things you do to make that easier?
One of the parts that we do in large-scale production, we actually had the customer add a little hole at the top of the part so that we could run a wire through it, and it makes the hanging process much easier on the vapor smoothing side. You saw this morning how time consuming it can be to hang every single part in that vapor smoother, and part of that's self-inflicted. I want the parts to be exactly right, but if you can find a way to hang 10 parts in 30, 40 seconds, it cuts down that processing time a lot.
Any engineer who does production is familiar with what you just said. How do you get seconds out of each part? It matters. SLS is the additive process that can get to quantities where that kind of thinking becomes impactful.
Changing a part in the software state is very easy. Whereas if we were trying to clean all of these out, we would maybe have to create a jig to hold them in a drill press to get all of the powder out. If you can add a little hole or add some windows or add some clearance or remove some material in areas, they're all ways that make production flow smoother.
What do design engineers most often overlook that limits the scalability of an SLS part?
How do we get the powder out? Adding some of these holes makes it easier for us to just put these in the blaster and they get tumbled and most of the material's removed Another thing I think is overlooked is the material usage and how that relates to the nesting of the parts.
You could have a designer who has embraced additive so much. They're doing part consolidation, they're doing lattices, they're lightweighting, they're getting this geometric complexity, and they could come to you, but you would look at it right away and, okay, you've just made a powder trap.
We can still work with whatever a customer sends us. It's just about communicating the limitations. A great example of this, I had a customer who designed a part around injection molding. We were able to print the part easy enough, but there were some cavities that were really deep. Just having him remove those cavities altogether saved us tons of time.
So you're really thinking about production. Are there examples of trade-offs that you think about in post-processing methods?
One of the bigger trade-offs, I guess, is adding windows. Now you get a more flexible part. Adding corks to parts, now you're adding extra material. But I always try to weigh the trade-offs with, is it scalable? Another example was we had a customer bring me a part, literally bring me his 3D printed part and say, I need a bunch of these. I don't think I can mold it. I'd like to just have this be 3D printed. What can we do? And so I took that part and I quoted it to him, and he said, well, that's a lot of money. Through SLA, he had it printed in a resin part, but it wasn't quite doing what he wanted it to do. And he came to me because he knew I did SLS, and he didn't love that price. Also, I could only fit, a certain number of them in a build frame. I took his file and I shrunk it a little bit in one area and I added some holes. I was trying to explain to him what the modifications I would make to make it better for in the price range that he wanted. We ended up with this latticed part that's shrunken down in minor ways, but I was able to double the amount of parts that I was able to fit in the build frame, reduce the amount of material that was being used, and because of all of those other features that I'd added, made it easier to clean, easier to produce. The original quote was like $80 a piece. And through these minor changes, we were able to get it to like $25 a piece.
So with that example, you alluded to nesting. How big a deal is nesting?
There are certain fixed costs with running the printer. If you can fit 200 parts in a print, each part shares a piece of that fixed cost. Maximizing the number of parts that you can put in a print means the lowest cost per part.
What's the most parts you've ever gotten out of one build?
They're about this big and I fit like 800 of them. Those are the things that kind of flex our creative problem solving. We always work towards scaling.
If a manufacturer less familiar with SLS recognized they've got a part that's at the right quantities, like hundreds, maybe thousands, and they recognize that SLS is the most effective process, what do you think is the aspect of that aspiration that they would most struggle with?
Keeping the mess down. That aside, I think the biggest limitation is consistency. How do you consistently get the same part out of your process? It really comes down to understanding the process from start to finish well enough that you can plan out how to do production consistently.
I want to explore a little bit more the mess. I've been to Lifestyle multiple times. I've always found this to be a clean facility. When you talk about mess, I think you're talking about there's powder, it's got to be contained and controlled. And what do you do to do production, do it at scale, but also keep a clean process, keep a clean facility all the way through?
Well, it's all related. I mean, we're doing medical devices. My grandpa always told me, you take care of your equipment will take care of you. And so we try to regularly maintain our equipment, keep everything clean.
SLS, as we said from the beginning, it wants to scale. If you're doing hundreds of parts, thousands of parts, SLS makes a lot of sense. And somewhere in the magnitude of 10,000, 100,000, million, somewhere in there, there's a line where it's going to be injection molding that makes the part, unless something about the complexity or nature of that component just precludes molding.
SLS can always be an option before injection molding, and they can work together. If this customer came to me tomorrow and said, I need 1,000 of those parts in a month, we could do it. It's easy. If you're trying to go injection molding, you're probably 6 months to a year before you even have the molds. SLS allows you that window to get product quickly, to get production quality product quickly, You can be building all of your mold and working with the mold designers in parallel. And while you're waiting that 6 months to a year for your parts to come out of the molds, we could have printed you 10,000 parts. My advice would always be start with SLS. Work through a lot of the hiccups of your designs. Get product to market quickly, and then if you deem it necessary to go to injection molding, great, I'll be here for your next project.
This episode's part of a collection on the SLS Mindset, how to design for selective laser sintering. Check out other videos in this series.